All right, welcome to another episode of the Scripting Them podcast. I am Fernando, your host, and today I want to talk about how to make or what you should look into from the architectural point of view to make sure that your applications are scalable. What exactly is a scalable application, and what architectural tricks or tips you can take into consideration when creating your backend. Essentially, we're talking about backend development here, platform development, if you will. We're in the age of cloud computing. We're in the age of massively consumed applications. So if you're in the business of building these type of applications, or if you're aiming to build an application that is used by millions of users, scalability is a topic that has to be in your mind. Maybe not at the start, maybe not while building your MVP, but eventually when you reach the point of saying, all right, now I need the user base to scale. Now I need people to really use my product. The backend needs to scale. So let's look into what that means and the type of actions that you can take and the patterns that you can follow from the architectural point of view to help you ensure essentially that your product will scale. Now, before we get to that, let's just make sure that we understand what scaling is. I kind of already hinted at it during the introduction, but the point is, the more users are using your application, the more resources are needed for it to function. Those are kind of the basics of it. We're not talking about now. We're not talking about the pattern or the type of architecture you have in the backend. It's just a simple one-to-one relationship. More users, more resources. Now, the more resources can mean anything based on the type of architecture you have. Usually, and I kind of already talked about this in another episode, if you have a monolith in the backend, scaling it's going to be a little bit more complex. Right off the bat, I would say that if you build your MVP around a monolith, the first thing that you want to do to ensure scalability is to break it up, right? Because if you have a monolith and you're expecting scalability to be a real need for your project, that means that probably there's like 99% chances that monolithic or a monolith is not really the right pattern for your backend, right? Because if you want to scale that, it means a lot more resources. It means you're scaling every piece of the backend in the same way. There are many downsides to trying to scale a monolith. So one of the first things I would recommend is just break it up into microservices. What microservices will give you, and again, you might want to look into episode 21, which is the one where I cover monolith versus microservices in more detail. But the point here is that microservices will make it a lot easier for you to scale. Why? Because you're decoupling the logic, first and foremost. You're removing any code-based coupling that you might have. Now you have completely different business domains that are independent from each other and interacting through some sort of interface, which usually are APIs. Now, this approach is easier to scale. Why? Because you can now focus on the type of services or specific services that require more attention. When you have a growing user base, maybe the first type of services or the first service that you want to scale will be like the login service, for example. So you make sure that everyone can go into your system without affecting the rest of the services, without affecting or without paying more for any other resources. Now then you can go from there, you can go into the next type of service that is being consumed and understand, which are the ones that need more scaling, that are suffering from more traffic, and start scaling those specifically. A microservice-based architecture also allows you to create fault-tolerant backend, essentially. You can add duplication of services. You can add even some sort of replica master scenario where if the master fails, you have replicas that will take ownership and will replace the master if there is a problem. So there are many benefits to using microservices. So the first thing that you want to do when thinking about scaling is make sure that your backend is based on microservices. Is this the only thing? Absolutely no. And is this something that will ensure that your backend will scale? It won't ensure. It will make things a lot easier, but there are other things that you can do on top of this to even simplify it and add certainty on the scalability capabilities of your backend. Now, everything else that comes after this is assuming that you're under the microservices-based architecture. Now, adding load balancing would be like a second step into this. Now you have the ability to have independent microservices. Now, a great way to scale them is just to duplicate them. How can you duplicate them and still have a simple to use architecture? Add a load balancer in between the client of those microservices and the full set of duplicated microservices. Now the load balancer will be your only endpoint, and through it you will distribute the load between the different copies of the same microservices. This goes hand in hand with ideally making sure that your microservices are stateless. This ensures that whatever request comes to the load balancer, it can freely choose whatever other copy of the microservice is available, and with the least load at any given time. If you don't have stateless microservices, what will happen is that if you don't control that, then the information that they have in memory will not be shared between each other. Essentially, and just to make sure that we're all aware, if the microservice is not stateless, it is stateful, meaning that it contains information in memory regarding the state of a specific request. So if you only have one microservice, it's not a big deal, right? Because every request from any type of user, any type of client, it could be other microservices, it could be like front end, they will reach all the same server, essentially, the same instance of the microservice, and the memory will be there, right? But now imagine you have 2, 3, 4, 5 copies of the same microservice. The first request lands on number 1, and it creates an in-memory state for that particular request. Now, the second request from the same client lands on the second microservice. The information from the original request is no longer there. It's no longer in memory because it's actually in the memory of the first microservice. See where I'm going? Stateful microservices don't really scale that well. There is a workaround to this, which is called sticky sessions, which allows you to say to configure the load balancer to like map clients to specific microservices. This doesn't really follow. This doesn't really help to properly scale or properly distribute the load between different microservices, because you can't really control how long these clients will be interacting with you. So some of these clients might interact for a longer time, and those might all land on the same microservice. While other microservices would have either less load or no load at all. So you're overloading some and underloading others. So it's not really the most efficient way to deal with scaling microservices. Ideally, what you want is the microservices to be stateless, meaning that all the information required to handle specific requests is within or is inside the request. Any extra information can be gathered from a database or even an in-memory cache like Redis that is outside of the microservices memory. That's completely fine because all of them can share the same database, the same memory cluster, if you will. So they would all have access to the same information. It wouldn't be sharded, essentially. It wouldn't be partitioned. But if you can assure that, if you can either making sure that the information is within the request, or if the extra information is in a place that is shared by all the microservices alike, then that's your ideal scenario, because you can now add copies of the same microservices put them all behind a single load balancer and let the load balancer distribute the load. And from a client perspective, either the website or another microservice, you're just hitting the same endpoint. You're just hitting the endpoint for the load balancer, and the load balancer is doing all the hard work for you. This is one of the ideal scenarios where scaling microservices is trivial, because you just copy and duplicate and redeploy something that is completely easy to do and cheap, especially if you're using like a managed infrastructure, so sort of like something in the cloud. Then doing this is completely and it's easy and a lot simpler than doing that manually. You can even automate that, which brings me to the next point, which would be auto-scaling. If you have an infrastructure that can be automated and resources can be created on the fly through code, then definitely, we're talking about cloud environment ideally, then auto-scaling is something that you have to look into. Without auto-scaling, what you have to do is either keep an eye on the monitoring solutions that you have manually and see the trends and figure out where scaling might be needed, and try to trigger that scaling of your infrastructure before it is actually needed. That might, in some cases might make you overspend money just to be sure. In some situations, you might be too late, and you might see problems with the performance of your application because you didn't get there fast enough. This is something that you don't want to be doing manually. So what happens usually is that you just overscale and overspend on resources to make sure that you're set for the foreseeable future in regards to the capacity of your backend. Now, this is not cost effective, as you could probably guess. And if you can automate the process of scaling, either scaling up or down, which is also crucial here because we're talking about saving money on resources that we're not using, then you have to look into it. You have to do it. All cloud providers allow you to perform this sort of auto configuration based on different metrics, based on resource allocation, based on number of requests. There are a ton of metrics that you can based off your scaling strategy, and you will probably need to tweak it over time to make sure that it's the best it can be. But off the bat, if you have something set up for this, you can sleep at ease knowing that if there is something happens overnight or during the weekend or whatever, the system will still be able to cope with the extra need for resources because it's been set to automatically respond to it. Now, other than your microservices, right? Because so far, with everything we've said so far, your microservices should not become bottlenecks. If you've been looking into them, if you've been monitoring them, if you've been tweaking the auto-scaling strategy, you might still run into problems, but not because of the microservices, but because of something else. Potentially, one area where people forget about is databases. Now, if you're in the cloud and if you're using a managed service for a database like RDS, for example, on Amazon, or BigQuery on GCP, it's not going to be a problem because those managed services will auto-scale without you having to do anything. But if you have like a standard server with your database and you manage it, or if you just have your own setup and you've been tweaking and making sure that your microservices can deal with all the load, but you just forgot about the database, then the increased amount of services now using those databases are going to collapse the database. You suddenly solve the big issue that you had, which was the ability for your services, your backend, to cope with all the new user base, to cope with all the new traffic, but you suddenly moved the problem to the databases. Now, I'm saying databases because usually all applications rely on at least one database. In some situations, many more. There might be other external resources that have the same problem. Maybe you're using external APIs that and your services rely on the information they get from them. optimizing that connection still is equally important as optimizing the connection with the databases. Now, in the databases, you're usually in control of. So make sure that whenever these databases can be clustered, they are. If there is a way for you to set up auto scaling for the databases, again, that's something that you want to look into. This is sort of generic because there are many different types of databases, from SQL to NoSQL, and within NoSQL, you have tons of different variations, and these projects all scale or behave differently. They have different scenarios where they are better at scaling than others. So you have to look into the solutions that you have specifically and see how they scale. Now, whatever solution you have, whatever product you have for your database, there's probably a version of it that can scale at least to one specific ceiling they might have, or they may not. Look into that, figure out how is the best way to scale it to make sure that it doesn't become a bottleneck. That's definitely one thing that you want to look into. And the other one is caching. If you have many database queries, you have to be smart about them and figure out if some of them repeat from user to user, or from service to service. If they do, then caching might be a good alternative. Using something like Redis is a fantastic idea for caching because it allows you to solve all caching problems almost automatically. Being in an in-memory database is incredibly fast. Being able to automatically delete all records is also something that simplifies the stale record problem within a cache. So you can definitely set a very powerful caching system in Redis with minimum effort, with minimum code changes. You will be removing tons of the load from the databases into Redis, and Redis is perfectly able to scale, to create cluster, and to grow almost indefinitely. So it's a good solution. It's a good thing to look into. If you don't know what Redis is, if you've never used it, I do have, this is a shameless plug, but I do have a course on Redis Essential that teaches you everything you need to know on how to use Redis from a technology agnostic point of view, essentially with any kind of language. So if you haven't really looked into Redis, I would advise you to look into it. I will add a link to the course on the show notes for you to look into. Finally, the last piece of advice that I would give, if you've done everything that you can, everything in your power to improve the microservice architecture and to make sure that everything is cached and your databases are able to scale and everything, but you're still seeing some bottlenecks, you're still seeing some problems with your architecture in specific peak hours where the response times for your services and thus the experience of your user is degraded, you might want to look into asynchronous architecture, or as I like to call it, reactive architectures or event-based architectures. These are all the same, essentially. When we think about microservices, we usually think about multiple microservices connecting to each other directly. So let's say for an e-commerce site, as a user, I'm adding a product to my shopping cart. That triggers a request to an endpoint on the main microservice that then triggers another request to the shopping cart service, and that triggers another request to the product microservice to make sure that there are still products available for purchase, and that also might trigger another message to the payment gateway microservice or to different microservices within your architecture. I'm making this up, but this is a very common thing. Microservices connecting to each other serially, essentially. So you have a chain of connections or requests that have to finish before the initial microservice is able to get all the responses and then send the response back to the user. That usually happens within microseconds, so it's not a big issue. But if you're under peak load, if your microservices are stressed out to their limits, or even the database is completely unable to perform faster, then all these slight additions of delays on each request will add up to maybe seconds of delay to the experience of the user, which is something that we don't want. So an alternative way is to have a centralized message bus, essentially, and all microservices are just connected to it, either listening for specific events or sending specific events. So let's go back to the same example and think, right, so I'm a user, I'm adding something to my shopping cart, and that triggers an event saying product added to shopping cart. That's it. Now that goes into the message bus and gets distributed to all microservices alike. Each of these microservices that are intended or that want to listen to this specific event will receive the event in parallel at the same time, and them themselves will be able to process that and send for the events in parallel. So let's say you have a very complex process in the backend that requires multiple microservices interacting with each other. You can achieve faster response times because there's a lot of processing that will happen in parallel. And then once the final one is ready and the response is sent back to the message queue, the information will be sent proactively, essentially reactively, to the front end, right? That is also hooked up into this message bus. Now that changes the type of interaction that your user has, because now the user will click a button and then get immediate feedback saying, we've received your request. They can just continue browsing, continue using your application without it being logged, waiting for a response. And when the response actually gets there, they will get a notification. In the end, I think that going with an event-based microservice architecture is the best way to scale, because you can use everything I've said so far about these scaling tips with, in conjunction with something that is event-based. And that will give you an incredibly flexible and scalable architecture. Mind you, it will also be harder to debug, and it will also be potentially even harder to create workflows and potentially harder to develop. But if you really need that extra level of scaling for your backend, then you might want to look into this. And that's it. And I just don't want the episode to finish without understanding this. All of this is based on you having a proper logging and monitoring solution in place. You cannot create a scalable architecture if you don't know what needs to scale, and if you don't know what happens in the backend and how the information is treated, and if there are problems, what are the causes of those problems. And that means monitoring and logging. Once you have that set up properly, then start looking into bottlenecks, start looking into potential solutions to those bottlenecks, start looking into errors. There are way too many options here, but the only way for you to actually know about them and come up with solutions for these problems is through understanding exactly what's happening. And that means monitoring and logging. Set that up first and then think about everything I said. Don't do it the other way around, because you might be over optimizing. You might be spending way too much time breaking things up into microservices that don't really need to be broken up. You might be optimizing servers that you think might require more resources when in fact the bottlenecks are somewhere else. So really monitor, log it, and then optimize it, then re-architect, if you will. And that's it. That's it for this episode. Remember, everything that you want to do needs to happen after you monitor and you properly log all your code and all your logic. Once you understand where the bottlenecks on your backend are, think about microservices. Think about load balancing in front of those microservices. Think about auto scaling strategies for your microservices. Think about the databases. Remember, don't forget about the databases. Think about your microservices. Absolutely improve your code, improve the architecture. But remember, there are databases that might be just overwhelmed by how much your ecosystem is scaling and you're just not paying attention to them. And finally, remember that if you need that extra juice, if you need that extra level of scaling, then event-based architectures might be the solution for you. They're just more complex to implement and maintain, but definitely worth the trouble. That's it for this episode. Remember, if you have any suggestions or if you want to reach out, links are in the description of the episode. Remember to subscribe to YouTube if you're watching this on YouTube, or to the podcast if you're essentially listening to this anywhere podcasts are distributed. I put out these episodes once a week, and if you want to learn about one specific topic, either front-end, back-end, or any other type of development, let me know and I'll research it and do my best. All right, until then, catch you in the next one. Bye. And that was it for this episode of the Scripting Them podcast. Thank you so much for listening. Remember that you can find me online on Twitter at TheDeepMan123, and you can also find the podcast YouTube channel just searching for the Scripting Them on YouTube. Thank you again, and I'll catch you on the next one.